Hello everyone, welcome you all to the 7th module on vacuum cleaner of the online course on domestic equipment maintenance. The previous module, that is module 6, deals with the basics of inverter and geyser. This module 7 has been divided into 2 sessions. In session 1, we will discuss on vacuum cleaner basics and working. And session 2 will be focused on vacuum cleaner operations and maintenance. Let us now come to the today's topic, that is vacuum cleaner basics and working, where we will focus on the basic construction of vacuum cleaner. Then we will learn about the working principle of vacuum cleaner. After that, various types of vacuum cleaner. Then the power consumption rating of vacuum cleaner. Then some common technical problems that occur in vacuum cleaner, and in the last we will focus on the safety considerations that we have to be considered during the handling of a vacuum cleaner. So now I will start the session by introducing a vacuum cleaner to you. What is vacuum? A vacuum refers to a space entirely empty of matter, known as an absolute vacuum. In practical terms, we use the term vacuum when the air pressure within a space falls below atmospheric pressure. Various national and international measurement units are employed for the measurement of vacuum level. The most commonly used units are Pascal and bar. The vacuum level is often expressed as a percentage value. However, these are always a relative values. Now, what is a vacuum used for? Vacuum technology plays a vital role in advancing research across the fields of chemistry, physics, biology, and it is equally indispensable in numerous industrial applications. Air consists of a mixture of gases containing approximately 10 to the power 25 particles per cubic meter under a standard atmospheric pressure of 1 bar. These particles exert pressure and force upon the walls of a confined space. The force exerted on the walls reduces as the number of particles within the space decreases. Now, pressure is equal to the force divided by area. Now, 100% vacuum would mean that there are no particles present. That means pressure equal to 0. A vacuum can be specified as an absolute value, that is with a positive sign from 1 to 0 bar, with 0 as absolute 0. Or it can be specified as a relative value within a negative sign from 0 to -1 bar, with 0 as a reference point or as a percentage. Now, a vacuum cleaner, often simply referred to as vacuum, is a household appliance designed for the purpose of cleaning floors and other surfaces by removing dirt, dust, debris and other particles. Vacuum cleaners operate on the principle of creating a partial vacuum or suction to draw the air and the particles it contains. This air, along with the collected debris, is often filtered and expelled, leaving the clean surface free from dirt. Dear learner, now let us discuss the construction of vacuum cleaner. The construction of a vacuum cleaner involves several key components that work together to create suction, collection and filter debris and facilitate the cleaning process. Key components of a vacuum cleaner are: number 1, motor. The heart of a vacuum cleaner is its electric motor. It generates the suction power required to pull in air and particles. The motor's power rating, typically measured in watts or amperes, determine the strength of the suction. The next component is the handle. The handle is an integral part of the vacuum cleaner's design, allowing users to push, pull, and steer the appliance comfortably during cleaning. Nozzle and brush roll. The nozzle, also known as the cleaning head, is the part of the vacuum cleaner that comes into direct contact with the surface being cleaned. It typically contains a brush roll or agitator with bristles. The brush roll rotates the loosened and agitated dirt and debris, making it easier for the suction to capture these particles. The next component is the suction system. The suction system of a vacuum cleaner includes a fan or impeller, which is usually connected to the motor. This fan creates a flow of air through the nozzle, drawing in air and particles from the cleaning surface. The next component is the power settings. Many vacuum cleaners have adjustable power settings or modes to accommodate different floor types and cleaning tasks. This allows users to optimize suction power for efficient cleaning. Attachments and accessories. Vacuum cleaners are often come with a range of attachments and accessories such as crevice tools, upholstery brushes, dust brush, bare floor brush, cleaning carpet tools, etc. to facilitate cleaning in various spaces and on different surfaces. The next component is controls and indicators. Vacuum cleaners typically have control on the handle or body that allow users to adjust settings such as suction power or brush roll speed. Some models also feature indicators for filter replacement or bag canister emptying. The construction of vacuum cleaner may vary depending on the specific type or model, but these components represent the fundamental element found in most vacuum cleaners. Together, they enable the vacuum cleaner to effectively clean floors and other surfaces by creating suction, collecting debris, and filtering the air. Now let us discuss the working principle of a vacuum cleaner. The fundamental operating principle of a vacuum cleaner involves generating a partial vacuum or suction force to attract air and the particles it carries, followed by a process of filtering and expelling the air while retaining the gathered debris. Let us now discuss the working principle of vacuum cleaner step by step. Step 1 is the airflow generation. The process begins with an electric motor located inside the vacuum cleaner. When we turn on the vacuum cleaner, the motor generates suction power by creating a flow of air. This suction is a low pressure area or partial vacuum generated within the device. This airflow is important for the cleaning process. Step 2. Nozzle and brush roll. The vacuum cleaner's cleaning head or nozzle contains a brush roll or agitator that comes into contact with the surface being cleaned. The brush roll's purpose is to loosen and agitate dirt, debris, dust, and make it easier for the suction to capture these particles. Step 3. Suction. The airflow generated by the motor draws air along with the dislodged particles through the nozzle and into the interior of the vacuum cleaner. This suction force is responsible for removing dirt and debris from the floor or surface. Step 4. Dust collection. As the air along with the particles enter the vacuum cleaner's body, it encounters a dust collection system. The type of dust collection system can vary depending on the design of the vacuum cleaner. They are bagged model vacuum cleaner. Bagged model vacuum cleaner. In traditional vacuum cleaners equipped with either disposable or reusable bags, and gathered debris gets trapped within the bag as the air flows through it. The bag functions as a filter, permitting air to pass through while capturing dirt and dust. Bagless model vacuum cleaner. Many modern vacuum cleaners use cyclonic separation or other mechanism to separate and trap debris without the need for disposable bags. This model often have a dustbin or canister where the collected dirt accumulates. Step 5. Filtration. To ensure that the air expelled from the vacuum cleaner is clean and free from debris and fine dust particles, a filtration system is employed. High efficiency particulate air filters are common in many vacuum cleaners. These filters capture tiny particles and prevent them from re-entering the air. Step 6. Exhaust. After filtration, the clean air is expelled back into the environment, leaving the collected debris trapped either in a bag, a dustbin, or another collection system within the vacuum cleaner. Thus, a vacuum cleaner operates by using an electric motor to create suction, which pulls in air and debris from the cleaning surface. The collected dirt and dust are separated and trapped, while the cleaned air is filtered and expelled back into the environment. This process enables efficient and convenient cleaning of floors and other surfaces in homes and commercial spaces. Dear learner, now let us show a demo video to know how a vacuum cleaner works. This is a vacuum chamber. In the upper part of it, there is a filter used to capture dust particles. This is a motor and centrifugal fan. This is the pipe attached to the cleaning device. When AC power supply is applied, the fan starts rotating and it will create a pressure difference. This pressure difference will suck the air through this pipe and the pipe suck the dust particles. This air with dust particle will reach the filter. Here it will be filtered and clean air will pass, which will reach the atmosphere. Dear learner, let us now do a self-check of our learning so far by attempting the following questions. Please attempt the following questions before progressing ahead to the next topic. So after attempting the quiz questions, we now go ahead to the next topic about the types of vacuum cleaner. Vacuum cleaners come in various types, each designed to meet specific cleaning needs and preference. Here are the most common type of vacuum cleaners. Number 1. Upright vacuum cleaner. The upright vacuum cleaners have a vertical design with the motor, dust collection system, and cleaning head that are integrated into a single unit. They typically have a handle for pushing and steering. This type of vacuum cleaner is easy to maneuver, well suited for large captured areas, and often have strong suction. But it may be bulky and less versatile for cleaning under furniture or in tight spaces. This number 2. Canister vacuums. Canister vacuum cleaners consist of a separate canister unit connected to a flexible hose and cleaning vents. The canister houses the motor and dust collection system. This type of vacuum cleaner is suitable for a variety of surfaces, easier to maneuver in tight spaces, and typically quieter. Drawbacks of canister vacuum include the necessity to pull the canister unit, along which some users may find less convenient. Number 3. Stick vacuum cleaners. Stick vacuum cleaners are lightweight and slim, often resemble a long stick with a cleaning head at the bottom. They are corded or cordless and designed for quick cleanups. Advantages of the stick vacuum cleaner are lightweight, easy to store, and ideal for everyday cleaning tasks. Disadvantages may include less power suctions and smaller dustbin or bags. Number 4. Handheld vacuums. Handheld vacuum cleaners are small portable units designed for spot cleaning and reaching tight spaces. They are usually cordless and held by hand. This type of vacuum is extremely portable, great for cleaning small meshes, and easy to store. Drawbacks may encompass limited capacity and runtime, not suitable for whole house cleaning. Number 5. Robot vacuums. The robot vacuum cleaners are autonomous self-navigated devices equipped with sensors and brushes. They move around the room, cleaning as they go, and can be programmed or controlled via mobile applications. They are convenient for automated cleaning, suitable for daily maintenance, and can clean under furniture. But it may not provide deep cleaning, and some models require manual emptying of the dustbins. Number 6. Hand stick or cordless stick vacuums. Hand stick vacuum cleaners are similar to stick vacuums but are cordless and often come with a removable handheld unit. They offer flexibility for both floor and above floor cleaning. Advantages of this type of vacuum cleaners are cordless, convenience, versatile for various cleaning tasks, and typically lightweight. It has limited battery life and may require regular recharging. Number 7. Wet dry vacuum cleaner. Wet or dry vacuums, also known as shop vacs, are designed to handle both wet and dry derbies. They have a robust construction and a large capacity than typical household vacuums. This vacuum cleaner is versatile for cleaning both wet and dry meshes, ideal for workshops and heavy-duty cleaning. Drawbacks include bulkier and heavier than standard household vacuums. Number 8. Central vacuum system. The central vacuum systems consist of a central unit typically installed in a utility area or garages. They connect to in-wall outlets throughout the house, and users attach a hose and cleaning head to these outlets. This is a powerful, quiet and convenient for whole house cleaning without a need to carry a heavy unit. Its drawback includes it requires installation, making it less suitable for apartments or existing homes without the infrastructure. Each type of vacuum cleaners that are discussed now has its own set of advantages and limitations. So the choice depends on factors such as the size of your home, the type of surfaces you need to clean, your cleaning preference, and your budget. Now, the next topic is the power consumption rating of vacuum cleaner. The power consumption rating of a vacuum cleaner depends on the type of the model, brand, and its features. The typical vacuum cleaner consumes 1400 watts or 1.4 kilowatt of energy per hour of uses. However, the power consumption of a vacuum cleaner ranges between 450 watt to 2500 watts. The actual power consumption of a vacuum cleaner may fluctuate due to factors like motor efficiency, adjustable suction settings, and the particular cleaning task it is employed for. To find the exact power consumption rating of a specific vacuum cleaner model, you should to consult the product's documents, which is typically available in the user manual or displayed on the product label. Dear learner, let us now try to understand the various technical issues or problems commonly encountered in a vacuum cleaner. Some of the common technical issues are: number 1, low suction force. Reduced suction force is a common problem and can result from clogged filters, a full dustbin or vacuum bag, or a blocked hose or nozzle. To troubleshoot this issue, clean or replace the filters. Inspect the dustbin or vacuum bag for sign of fullness and check for any obstructions in the brass roll to ensure it is unobstructed. The next common issue is the brass roll issues. The brass roll responsible for agitating and picking up dirt can become clogged with hair and debris, or its belt may break or become loose, leading to reduced cleaning effectiveness. To resolve this problem, examine the brass roll for entangled hair or debris and perform cleaning if required. Also check if the belt that drives the brass roll is intact or needs replacement. The next issue is the motor problems. The electric motor of a vacuum cleaner can fail due to overheating, worn out carbon brushes, or electrical issues. This can result in a loss of power or strange noise. Additionally, check the motor housing for any foreign objects or debris that could obstruct the motor's function. Similarly, inspect the power cord for any signs of damage. Another issue is the burning smell. A burning smell can indicate overheating or a motor issue. It is important to address this issue promptly to prevent further damage. For resolving this issue, turn off the vacuum immediately and let it cool down and consult a professional for repair. Overheating. Vacuum cleaner overheating allows the vacuum to cool down if it has overheated. Ensure that filters are clean and the air flow is not restricted. Check for blockages in the nozzle or hose. Excessive noises. Unusual noises like grinding or rattling can result issues with the brass roll, motor, or other internal components. Inspect and remove any obstructions. If the noise persists, consider professional repair. Another issue is the leaking. If you notice water or dust leaking from the vacuum cleaner, it may indicate a broken seal, hose connection, or a damaged dustbin or bag. To troubleshoot this issue, inspect the dustbin or bag for damage or improper installation. Examine for loose hose connections or damaged seals. Another issue is the battery issue. For cordless vacuum cleaners, battery-related problems such as reduced runtime, failure to charge, or quick discharge can occur. Ensure that the vacuum's battery is fully charged. Additionally, verify that the charging station is functioning correctly. While vacuum cleaners bring great convenience to our lives, they can encounter common technical problems. Familiarizing oneself with these issues help in troubleshooting and maintaining the efficiency of the device. However, for some serious issues like motor or electrical problems, it is advisable to seek professional repair or replacement. Regular maintenance such as cleaning filters and brush rolls can help prevent many of these common issues. So dear learner, now let us discuss some safety precautions while handling a vacuum cleaner. To ensure safe and efficient operation of vacuum cleaner, it is important to follow a few basic guidelines. Some safety precautions to keep in mind when operating a vacuum cleaner are: number 1, when the vacuum cleaner is not in use, unplug the vacuum cleaner from the wall outlet. This protects the cord and plug and helps prevent accidents. Never vacuum a wet surface. This can damage the motor of the vacuum and puts the user in danger of experiencing an electrical shock. Number 3, never drop a vacuum cleaner. If a machine is accidentally dropped, have it checked by a certified technician before using it again. Never pull a vacuum cleaner by its cord and keep the cord away from sharp edges or corners. Number 5, never use a vacuum cleaner without slippers. Keep fingers away from all powered moving vacuum cleaner parts. Keep vacuum cleaners away from children and pets. Do not clean up toxic or flammable materials with a vacuum cleaner. Do not pick up hard or sharp objects including glass, nails, screws, coins, etc. with the machine. Always store vacuum cleaners in a cool and dry location. Dear learners, at the end of the discussion, let us now test our learning by attempting the following quiz questions. After you have attempted these quiz questions, we now come to the end of the session on vacuum cleaner basics and working. In this session, we have discussed about the use of vacuum, basic components of a vacuum cleaner, working principle, its different types, power consumption rating, and common technical problems in vacuum cleaner, and in the last, some safety precautions while handling a vacuum cleaner. The upcoming session will focus on the topics of operation and maintenance of a vacuum cleaner with live videos. Please do not forget to post your queries and give your feedback on the session. See you in the next session with some more practical topics about the vacuum cleaner. Thank you.